Hi students, today we are going to learn gravitation. For that, I would like to introduce you two people. One is you and another person is a very famous person who is the President of United States of America, which is Joe Biden. So this is you and this is Joe Biden. So what I'm going to say now is quite weird, so you should understand. I would say you and Mr. Joe Biden has an attraction. I'll repeat, you and Mr. President of America has an attraction. So what's your take on it? Whether you like him or not, you both has an attraction. So to find the gravitational force of attraction between you two, we have to find the gravitational force of attraction of you and Mr. Joe Biden is your mass, which is 50 kg, multiplied with the mass of Mr. Joe Biden, divided by the distance separating you. You are sitting here and Mr. President is in White House. So approximately we are taking just 1000 kilometers. Okay? It has to be divided by the square of the distance separating you two. This is an approximate number. Okay? I'm just put a number in random and in turn multiplied by a constant, which is 6.67 into 10 power minus 11, or we normally say it as capital G, which is called gravitational constant. Okay? So the force of attraction, the gravitational force of attraction is calculated by the constant G multiplied by the mass of first object and mass of second object divided by the distance separating them square. Okay? What will be the unit of force? What will be the unit of gravitational force? So of course, since it is a force, the unit of gravitational force is of course Newton. Okay? So this is how we'll get the force, the gravitational force of attraction between two masses. Do you understand? Okay. So now we are moving into what is a gravitational field, how it works. Okay? Gravitational field. So what is a gravitational field? Okay, so we are told you and Mr. Joe Biden has an attraction. So how is this attraction working? Okay, for that there has to be some kind of field that should pull. Okay, there has to be something now that will pull. If I pull something here, it will come. Okay, there has to be some kind of activity or field that has to be there to attract an object. So in that manner, we have came to a conclusion that there has to be a gravitational field in which a mass is sitting, so it is getting attracted. Okay, I know that you didn't understand what I said, but I'll come to an analogy that will make it the thing easier. Okay, imagine a spider. Okay, imagine a spider. Let it be a spider, please. Okay, so this is a spider web. Of course, you would have watched all kind of Spider-Man movies. So this is a spider web. Okay. What if an insect gets stuck here? Imagine an insect getting stuck in the spider web. Why it is getting stuck there? It has an attraction. It is getting stuck due to the attraction of spider web. Okay, and the spider can easily get it. Similarly, gravitational force of attraction needs a gravitational web to attract, and the web acts like there has to be a field that is started from the object and has multiple levels of spreading. Okay, so we'll come to this case. Imagine there is a infinitely long field which is not visible to eyes of Mr. Joe Biden is spreading across the universe, and you are sitting in that field. Okay, you are sitting in that gravitational field that is generated by Joe Biden. Okay, so it is like this is Joe Biden and this is you. So of course there will be an attraction. So to understand the concept of gravitational field, it is like a spider web that has a length of infinity and spread across the whole our universe. Okay, so you have a gravitational field which has an infinite length. So whatever object which is placed in that field has an attraction. Similarly, Joe Biden. Similarly, any other object has a gravitational field around it which is generated by itself, which is in turn sitting in a gravitational field of me or you or Joe Biden. So every mass is producing a gravitational field. So in that field, every other mass is sitting. So that is how the concept of gravitational field is working. So that is how the gravitational force of attraction is working. So we are going to learn the laws of motion. Okay, we are going to learn what are the laws of motion, the important part of physics, one of the greatest milestones that Newton has arrived. That is what we are going to learn. For that, there are three laws that we want to understand. Three laws: Newton's first law, second law, third law. Okay. So I'll explain in a very, very different manner. Okay. So imagine you are sitting in a roller coaster ride. Okay. So you are sitting in a roller coaster ride which is about to start. Okay. So you are sitting here at the front. Okay. It is about to start. Will the roller coaster move as it's on? We need a push or pull to start the motion. Am I right? So unless we act a force upon this roller coaster, it will not start moving. Am I correct? This is exactly Newton's first law of motion. Unless an object is acted upon by an external force, it will continue to stay at rest or continue its motion. If it is moving, we need an external push or pull to stop or increase the speed. Otherwise, if it is in rest, it will continue to stay rest until we act a force. So this is called Newton's first law of motion. Otherwise, it is called law of inertia. So what is inertia? Inertia is the inability of a body to move as its own. So that is why it is called law of inertia as well. So I hope you understood what is Newton's first law of motion. Correct? Now we are clear with first law. You got the concept. Alright? Now we are moving to second law. Okay? Yeah. So now the roller coaster has started moving. Okay? It is moving. So imagine, so you and the roller coaster and your team is about to hit a water body. Okay? So what will happen if it hits the water body? The water will spread. The water will spray like anything to the neighboring places. Okay? So imagine if you are coming in a very high speed from a high steep place. So what will be the area that will spread by the water body? So the water will spray to the maximum area. Am I correct? It will get sprayed. So the force on the water is the factor that will make it spread everywhere. Am I correct? So what if I am coming in a very fast manner? If you are coming very fast, the water will be moving towards the maximum of its distance. If it is slow, it will not go further. So the force acting on the water body depends on the mass of the total people sitting and the roller coaster's mass and the acceleration of the roller coaster. Okay? So that is exactly what second law is. Okay? The force applied is directly proportional to the mass of the body and the acceleration of the body. You understand? So the Newton's second law states that the total force or the force applied is directly proportional to the mass of the object and the acceleration of the object. There are some more definitions also. We'll explain to it later. Okay? Now you got the concept, right? So now we are clear with Newton's second law. So we are moving to third law. Okay? So Newton's third law of motion. So for that, to a better understanding, we'll take the same example and we are moving forward in a roller coaster. Okay? If you are moving forward in a roller coaster, when the roller coaster moves forward, when it speeds up, you will get a force towards the seat itself. I'll explain one more time. When the roller coaster pushes you forward, your body will exert a force on the seat. Have you experienced it? So it is moving forward and you will be like this, because it will be acting, your body will push you against the seat. So that is exactly Newton's third law of motion. For every action, there will be an equal and opposite reaction. So if I push the board like this, why I am not getting penetrated and going inside the wall? Because the wall is pushing me back. So the same force what I acting on the board is acted by the board on me. So we are pushing equal but opposite. So that's how Newton's third law works, which is called action reaction pair. Okay, there will be an equal and opposite reaction to every action. So now I have one question. If the force and the reaction is same, why it is not getting cancelled? I said when I push this wall, my hand on the wall is exerting a force, and the wall in turn exerts a force on my hand. Am I correct? So why these forces are not getting cancelled? I'll explain. To get cancelled, if two forces are getting cancelled means the two forces has to be exerted on a same body. Okay? So imagine on my hand, this body and this one is pushing. Okay? My hand is getting pushed by this one up and this one down. Okay? My hand is the object that is getting pushed from both sides. Here, these two forces will get cancelled because these two forces are acting on a same body. But in this case, when I push this board, my force is acting on this body. Am I correct? And what about the reaction force? The reaction force of this board is acting on my hand. Even though the force is equal and opposite, both are acting in different bodies. So how come it will get cancelled? So that is a conceptual understanding that you all should have. It will not cancel because it is not acting on the same body at all. Okay, so for the sake of general information and the conceptual understanding, I have explained this. So now you understood what is third law as well. So first law is law of inertia. Everybody needs a push or pull, an external force to continue to change its direction or change its speed. Okay, that is called the law of inertia as well. And Newton's second law of motion, which is the force applied is directly proportional to the mass and the acceleration of the body. And Newton's third law, for every action there will be an equal and opposite reaction. So these three laws constitute the physics in the first half of physics, I would say. There are a lot more to understand, and what I explained right now is just a concept, and there is a lot of things to be discussed, so we'll do that. Okay, thank you.